Good morning, everyone. If you're expecting to hear about cloud strategy and vision, you're in the right place. Our presenter for this session is Henry Jenkins, who is a Senior Director for Enterprise Infrastructure. Welcome, Henry.
So good morning, everyone. As Bob said, I'm Senior Director of Enterprise Infrastructure within OIT. Enterprise Infrastructure is the division that provides server storage, network, telecom, data center, and cloud services to the campus. Today we're going to be talking about why OIT is using the public cloud, specifically Amazon Web Services, AWS. What it is that we have done, how our journey has been over the last few years, and what we've learned from that journey, as well as where we are positioning ourselves for the future in terms of not only bringing services to those, or using the cloud to take advantage of its features for those applications that live in our data center today, but also to create campus-facing services for faculty and students tomorrow. So first, I want to level set with you all on what I mean by public cloud. Sometimes people have an idea of what cloud is. We talk about infrastructure as a service, platform as a service, software as a service, all these as a service things. What we're speaking to specifically today is the public cloud defined by the National Institute of Standards and Technology. What they talk about when they mean cloud is that you can get resources on demand from the cloud provider automatically and quickly. That you are able to access those resources across the network, primarily the internet, from practically any device. That those resources are provided from a pool, something called multi-tenancy. It's a lot like you rent an apartment within a larger complex. Just know that behind the scene, things are shared. Even though your own stuff is treated as its own private space. Rapid elasticity, meaning that in the cloud you should be able to create more of the same thing, called horizontal scaling, or add to what you have very rapidly, called vertical scaling. And finally, it's a measured service, meaning you get billed for what you use. So when OIT took a look at AWS and said, is this something of value to us? We took a look really across 4 dimensions. We looked at cost, what the difference was between AWS and our on-premise data center, time in terms of getting resources online, what the impact would be on staffing, and what the impact would be on control over those resources. For AWS, you pay for what you use, so the cost is variable. You don't know month to month necessarily what it is that you're going to spend. On-premise in a data center, you do. You buy your storage or your server, you get maintenance on it, and you can predict that cost over 5 years. For time, let's say we're buying that hardware, it can take weeks, if not months, for it to finally get on site, get racked and stacked, plugged in, configured, and then be ready to use. But in the cloud, it's practically instantaneous. For staffing, an on-premise data center requires on-premise people to run it, as well as people to do the racking and stacking and the ordering of equipment and make sure that those things are running and patched all the time. For the public cloud, you are paying for somebody else to do that for you, meaning the people you have are solving problems instead of just taking care of day-to-day challenges with hardware and facilities. On-premise, you have a great deal of control over the features that are added. They tend to be rolled out fairly slowly and deliberately because of all of the interdependencies and complexities that on-premise computing brings. In the cloud, you're giving up some of that control in order to get new features. But sometimes features get taken away and you only have X amount of time to be able to adjust to that. So even with that last caveat, there were an awful lot of advantages that OIT OIT saw that AWS could bring to the computing environment of the day. So OIT said, well, why not start the cloud journey? And we did. And we did it with a lot of small experiments, with our own software development teams going out into the cloud to build what they thought they needed and to really trial how AWS could be an advantage for OIT. In many cases, starting small with web servers or single server applications, just really simple workloads, and then slowly getting a little bit deeper into the pool as they experimented with larger applications, whole test and development environments, and ultimately being able to provide transactional internet-facing systems that serve people beyond campus, like our UC Recruit system today. All of this told us, yes, there's an advantage here. There is something there in AWS that we think we can use within the enterprise environment. But the thing about the enterprise environment is it's a lot like the difference between building a single-family residence and a mid-rise condo. They both have bathrooms and living rooms and dining rooms, but building a mid-rise to a high-rise is going to be more complex and going to require a lot more design and forethought. And so what we learned, or what we found, was that from the positives, these small teams were able to be very agile. They were able to get resources very quickly. They didn't have to wait for hardware to come in. They were able to learn a lot about how to build applications in the cloud that took advantage of those features. And probably the most important, their experiences drove confidence throughout OIT that yes, we could take advantage of what the cloud promises in terms of a small investment now to experiment, in terms of getting things up and running more quickly, bring those advantages into the enterprise environment. However, to go from that single-family residence to a mid-rise condo means we had to think about some other things that they experienced that wouldn't work in that larger environment. So some of the misses that we had, billing was done on an individual account level. So what that means is various different teams got various different bills. There was no overarching view, and therefore no overarching budget control or volume discounts, no way to aggregate that spend. There was no consolidated view of performance and availability. What does that mean? Well, if you are OIT and you are serving 1,000 applications to campus, then you want to know when any of those applications go down from a global perspective. You want to know whether you have to pivot the team towards an outage and take care of it, or if you've got other systemic issues going on. However, when you have monitoring and availability at the team level, that stuff doesn't become visible, and that's a problem in the enterprise. Inconsistency. While we had a lot of small experiments going on, a lot of people were learning a lot of great things, what we didn't have was a consistent set of security and operational practices. Different people interpreted security requirements differently, interpreted operational requirements differently. And what that meant was we didn't have the same picture and the same understanding of whether the stuff we were putting out on the internet, applications and data, things that were now more open to the world, were actually being protected to the same level as other like things. Again, that's a problem in an enterprise where you want to make sure that everyone's playing at the same level of security required for what they're doing. The final miss that we discovered was that if you have a lot of people trying to do the same thing and doing it a little bit differently, you create waste. So it's true that we learned a lot, but when everyone's trying to build the same border pipeline, in other words, the same security between the internet and their applications, when everyone's trying to build the same domain name services that's translating a friendly URL into the actual underlying IP address, when you have people trying to connect those back to identity services here so that people can use their username and password like they have on campus, and everyone's doing that work and doing it a little differently, that's just wasted effort. And when you get to an enterprise, you want to do things differently. So, what did we learn? Well, first of all, we learned, yes, there are advantages to cloud, but now we were going to set some enterprise objectives. This would be truly the first version of AWS that was enterprise grade. We wanted to make sure that we standardized the environment, standardized on our tools, standardized on our practices. We wanted to make sure that we had a common set of security requirements and a common set of answers, both process as well as tools, to be able to secure that environment. We wanted to ensure that we had a common, a holistic, if you will, visibility into performance and availability. We wanted to promote efficiency, to make sure that things were actually, that the environment was as cost effective as possible. And we wanted to do something new. Instead of building new applications in the cloud, the way that the enterprise, that OIT could take advantage of the cloud on behalf of campus, we saw as migrating existing applications from our on-premise data center and taking advantage of those cloud features by putting them in the cloud. So how did we decide to tackle that? Well, one of the things we noticed when you put on your enterprise goggles is that you need a broad view, and you need to design an environment that's going to work for many different kinds of applications. So we went out and we got an architect. We also knew we needed someone to build out those environments, to build some of those common services that I mentioned, things like the security going out between the internet and the workloads in AWS, the connections back from AWS to campus to be able to consume services that we have here today, like credential services. For that, we needed an engineer. And on top of that, we figured, we were probably going to be doing some migrations. That's the whole point. We need a project manager. So we formed a small cloud team of 1.5 people that did all that. So a little bit of a shoestring. But again, the cloud invites small experiments like this. We created a master account structure in order to consolidate and control billing and budget. And we did that through the account structure that AWS offers using a master account and various sub-accounts. Those sub-accounts are related to credentials, your identity, as well as to the workloads that are put in those. But they don't necessarily protect the workloads. You still have to build these virtual private clouds to put the individual workloads in and build additional security around them so that you maintain a separation between, say, your development environment and your production environment. We employed more automation and a common set of automation tools, using Terraform to build out environments and Ansible to build out workloads. We employed a moderate security model and mapped controls into that model. We also used some on-premise tools, primarily around security, to try to enforce the moderate security requirements that we identified. That was phase one. Phase two was to then put things into that new AWS environment. The idea was we create some basic shared services. I talked about that, being able to have a border between the internet and between these workloads and these VPCs that would be potentially at risk if there wasn't the right kind of security. We would focus on what we thought were cloud-ready applications within our data center. We would incorporate resiliency and disaster recovery through snapshots for backups, as well as multiple availability zones, which are like multiple data centers within a small geographic region, and even look at multi-region data centers. And we figured that this team of 1.5 people could do this, working in conjunction with application owners and all of that. Well, wrong. We learned a few things here too. And we were wrong for a couple of reasons. One is that we didn't find, what we found was that our environment is way more complex than what we really thought. And one of the exciting things about trying to make this journey to the cloud is we really discovered a lot of the interdependencies we had. And holy cow, we've got a huge amount. And those interdependencies are really critical to running the IT operations and serving the applications that serve the administrative, academic, and research stakeholders on this campus. Well, what does that mean? Recently, the University of California promulgated a policy called the Electronic Information Security Policy 3. And it classified those kinds of key critical dependencies as high risk, high security risk, meaning that moderate security model we had and the map that we thought we were going to follow just got blown up. We couldn't use that environment anymore. So we learned that we had a complex environment full of key dependencies, as well as, with any complexity, we needed far more people and far more time to migrate these complex applications into the cloud. So we didn't see a whole lot of advantages here. We had to go back to the drawing board. We did gain a lot of good things: the consolidated billing, consolidated visibility, consistency and security, all of those things. But we saw we couldn't advance. So back to the drawing board. Where we are today is that we've got that AWS 1.0 environment, and we've got some workloads in it, but we are now developing for the next generation of applications and new services. And we're doing it in a way that we believe the security model, the security requirements will be met for critical applications, and we will do it in an agile, scalable way. We're also trying to hit the objective, and I think we are mapping to the objective of cost optimization. Not just aggregating our costs under one master account, but also leveraging new system-wide discounts that we've signed up for, and being able to bill those back as we look at adopting campus users into this environment. We are looking at enhanced resiliency and security. We found that applications do not on their own take advantage of all those great things that I mentioned, availability zones and multi-regions. They don't do it on their own. Applications have to be architected for that. The result of those changes and objectives are to get to a faster migration, faster set of migrations, and to finally develop campus-facing self and managed services for faculty in research and academia who don't have access to those today, and to make it fast and easy like a vending machine. So agile and scalable security, right now we have gone through the exercise of mapping those information security 3 policy controls into AWS. We have a design, we're undergoing implementation now. When we are done, we expect to be able to enforce standard security so that whether it is someone internal to OIT or whether it is someone external to OIT, we are able to provide an environment with a consistent set of security controls and configurations to ensure that we are all playing at the same level.
5 minutes.
Well, I better speed it up. We have already taken action to optimize our costs. In fact, driving down costs another 11% starting in November by consolidating all of that billing under a single master agreement and getting to and accessing system-wide a system-wide UC agreement that just came out. We're working on enhancing resiliency and redundancy, which we're going to find primarily in the re-architecture of applications. by, again, leveraging multiple availability in regions, as well as testing our DR, making sure as we move applications, they're designed for disaster recovery, not bolted on as an afterthought. And we're also looking to accelerate our migrations. We know we need to get more people involved. And what that means is we need to train up other teams within OIT who take care of other technical parts. As far as campus-facing services, this is really the part we didn't think of as much in AWS 1.0, but we are in 2.0. And what we expect to do is build this service foundation that will allow campus users, that will enable campus users and campus-facing services to exist. And that means getting the billing right, getting the recharge right, getting the security model right, and ensuring that campus is able to take advantage of the kind of cost savings we have. In terms of the services we see a need today to provide web hosting and virtual hosting, much as we do in our data center. We also see a need to provide OIT managed services to campus around content management for web servers, systems administration for Linux and for Windows, and a secure research environment, something we have on premise today, but we expect to extend into the cloud to take advantage of all of the agility and cost savings there. Our roadmap looks like this. Over the next 3 years, starting last quarter, we expect to be investing heavily in the design and the build of our new environment. We expect to be investing heavily in our people to be able to migrate today's enterprise applications in the cloud and provide an environment and provide services that are easy to use for academia and for research. That's it. I think I've got a couple minutes. Are there any questions? Yes.
Microsoft shops on campus, can you comment maybe on Azure versus AWS and any experience with?
Yeah, so great question. The UC system has contracts with both Azure and AWS. So either provider can give you a reasonably good cost experience. With AWS, we've seen a lot more movement in consolidating all the costs around the UC system and driving those lower. The reason that OIT is currently settled with AWS is because it's more than just technology that makes a public cloud work, especially for an enterprise. It's about the kinds of processes and the kinds of process, and I'd say the kinds of design that go in there. Anybody can swipe a credit card to start up an application. You know, that gets us back to our distributed small experiment model. But when we're looking at, we want to build that mid-rise condominium tower, that's when it gets to, we need to know that our processes are mature enough that we can learn how to map those to a new environment. So that's why we're focused on AWS today. It's not that we don't see ourselves going to a multi-cloud world, we totally do. But we started with AWS and we're getting smarter around the processes and the requirements, the tools, and the controls we need. So once we feel we're mature enough, we'll be ready to then map those into a new environment and try to take advantage of that.
1
Did that
minute.
answer your question?
Quick
Yes.
question. When I think of cloud technology, I think of pretty much, you're stuck in a way with, whatever DR processes or locations that they have. And I think you mentioned on your presentation that you have that capability to select a different location. How flexible is that? Is that a lot of locations that you'll be able to, options there with regards to DR?
Yeah, so good question. I used to work in financial services and healthcare. The general rule of thumb was if you wanted a DR location, in other words, a secondary data center to run your applications out of, you would have that about 100 miles away. That way it would be out of the earthquake zone. If you were in another state, it would be tornadoes or floods or whatever. So here in California, specifically to UCI, we know we're in an earthquake zone. We today have a very narrowly focused limited DR program for the workloads that currently live in our data center on the site. So getting into the cloud and being able to leverage not just availability zones, which would be like having 3 data centers here on site on campus where we could switch workloads should one go down. That's good, that's resiliency. The actual recovery, being able to leverage another region, which we could do either by backing up, by taking snapshots of existing applications, copying those to a different region, such as Virginia, we're operating out of Oregon today, and then recovering them from backup, or, depending on the criticality of the application, designing it to actually run. If if Oregon went down, to run from Virginia seamlessly or almost like that would be another opportunity. But applications need to be designed for disaster recovery. They don't just get it automatically by putting it in the cloud. Am I out of time, Bob?
Yes, we're out of time.
All right. Well, thank you all for your time.